Melbourne's sewerage story is one of transformation, driven initially by crisis, sustained by engineering, and now evolving into a model for sustainability. In this final episode, we reflect on where we've come from, how the system has evolved, and what lies ahead as we plan for a future shaped by growth, climate change, and innovation. So let's roll back to where it all began. In the mid 1800s, Melbourne's streets were lined with open drains and cesspits. Water flowed untreated into laneways and into the Birrarung, and into the same water people relied on for drinking. Outbreaks of typhoid, cholera, dysentery were very common. The city was booming, but its sanitation systems were collapsing under pressure. The turning point came in 1891 with the creation of the Melbourne and Metropolitan Board of Works, the MMBW. Engineers were given the authority to design and build a comprehensive underground sewerage network. The result was one of the most ambitious public health infrastructure projects in Australia's history. A centralised, gravity-fed sewer system. The main outfall sewer, stretching 27 kilometres to Werribee. The pumping station at Spotswood, used to lift sewage from low-lying areas. And a treatment farm that used natural processes to clean waste and grow food. This was engineering vision applied at scale, and it changed the city forever. The lessons from that era still guide us today. Plan ahead, build for resilience, and think in systems. Fast forward more than a century, and Melbourne's sewage system is among the most advanced in the world. It's a hidden network, more than tens of thousands of kilometres of pipes, dozens of major scale pumping stations, 2 major treatment plants, and numerous other smaller ones throughout the outskirts of Melbourne, serving over 5 million people. But that network hasn't stood still. Over the decades, we've seen major upgrades, from the expansion of sewer mains to reach new suburbs, to the construction of the Eastern Treatment Plant in the 1970s, and more recently, the adoption of smart sensors linked with SCADA monitoring and energy recovery systems. Today, Melbourne sewers don't just remove waste. They're central to a broader ecosystem of water recycling, emissions reduction, and urban resilience. Here's what's changed. Real-time flow monitoring helps detect blockages, predict system surges, and prevent environmental overflows. Biogas recovery at the Western and Eastern treatment plants turns methane from sewage into electricity, powering treatment and reducing emissions. Class A water is now piped into parks, farms, and homes across the city. And nutrient recovery utilises biosolids for reuse in agriculture and other beneficial systems. But the job's not done. Melbourne's population is projected to reach 8 million by around 2050 or so. And that means more wastewater, greater pressure on ageing infrastructure, and increased environmental risks. At the same time, climate change is making our rainfall patterns more extreme. And whilst this might stretch out existing sewer capacity during drier spells, it'll overwhelm them during storms and extreme weather events. Engineers now face a new set of challenges. Managing higher wastewater volumes from denser urban living, preventing sewer overflows during storms and heavy rainfall events, meeting tighter environmental regulations for water discharges, and decarbonising infrastructure in line with net zero targets. The future of sewage and stormwater is no longer just about moving it away from people as soon as possible. It's about integrating water resources appropriately into urban systems, closing loops, and designing with circular thinking in mind. Let's look ahead to where we're heading. First, advanced recycled water. Melbourne is already recycling treated water for non-drinking water uses, but the next step may be using purified recycled water to supplement our existing drinking water supply. This technology already in use in Singapore, California, and parts of Western Australia, removes even trace contaminants through microfiltration, reverse osmosis, and ultraviolet disinfection. It's not just technically feasible, it's a potential game changer for long-term water security. Next, decentralized infrastructure. Rather than relying on large, centralized systems, future sewage designs may include smaller, decentralized treatment nodes. These could support local wastewater recycling, reduce pressure on existing trunk mains, and enable modular systems that are easier to adapt and maintain over time. Third, microplastics and emerging contaminants. Sewage today contains everything, from cosmetics to pharmaceuticals. The treatment plants of the future will need to remove not just organic waste, but also microplastics, PFAS, endocrine disruptors, and other persistent pollutants. This demands innovation in filtration technologies, chemical treatment processes, and tighter regulation. Finally, smart adaptive planning. Melbourne and other regions of Australia are now shifting their mindset from reactive to proactive by thinking ahead of the risks and opportunities yet to evolve. When making decisions in the present day, scenario considerations are more regularly thrown into the planning mix, with the aim to create designs which can flex more easily to manage risks and opportunities better than in the past. This shift from infrastructure as static assets to infrastructure as adaptive systems may be the most profound transformation in generations. But at its heart, Melbourne's sewage story is still about people, the engineers who built it, the planners who upgraded it, the communities who rely on it every day and help fund its operation. It's about decisions made decades ago that still shape how we live, and decisions we're making now that will shape the city our future will inherit. And it's about values: public health, environmental stewardship, innovation, and a belief that great infrastructure can make cities not just functional, but fair, sustainable, and resilient. From the crisis of the 1800s to the climate challenges of the 21st century, Melbourne's sewage system has been evolving, quietly, steadily, and with purpose. If we keep learning from the past and invest boldly and bravely into the future, we'll be ready for whatever comes next. Thanks for joining me in this series on Melbourne's sewage system, its origins, its evolution, and its future. I hope that it gives you a new appreciation for the infrastructure beneath your feet and for the people working every day to keep it flowing. I'm Paul Michael Angus. Thanks again for joining me throughout this series and also my other series of videos.